Have you ever noticed that when the moon or the sun appears right on the horizon, they're not actually there? It's true. When you see the sun just above the horizon at sunset, it's already physically below the horizon. Similarly, during sunrise, the sun you see peaking above the horizon is still technically below it. The same phenomena apply to the moon. This fascinating illusion is caused by the refraction of light in our atmosphere. When the sun is setting or rising, its light enters the Earth's atmosphere and bends, a process known as refraction. This is similar to the way a pencil appears to bend when placed in a glass of water. Refraction occurs because light travels at different speeds in different mediums. The extent to which a light wave bends depends on its wavelength, the density of the medium it enters, and the angle at which it strikes the medium's surface. When light moves from a less dense medium, like air, to a more dense one, such as water or denser atmospheric layers, it bends towards the normal, an imaginary line perpendicular to the surface. Imagine the refraction of light as similar to a car driving along a road. If the car's two wheels on one side suddenly hit a patch of sand, those wheels experience more friction and slow down. This causes the car to veer towards the side with more friction. In the case of the atmosphere, as light passes from the void of space to the air of the atmosphere, and additionally from the less dense upper layers to the denser lower layers, it follows a slightly curved path concave to the Earth's surface. Light rays traveling straight down don't bend, but those entering the atmosphere at a shallower angle are refracted, bending towards the normal and roughly following the Earth's curvature. This bending effect makes celestial objects, like the sun, appear higher in the sky than their true positions. This means that celestial objects in the zenith position directly above us appear in the correct position, while objects closer to the horizon appear to be higher up in the sky than they actually are. The lower the objects are on the horizon, the greater the effect. When the light traveling along a curved path reaches our eyes, our brains, not knowing the light was bent, extrapolate a straight line back to perceive the direction from which it originated. Thus, the sun or any other celestial object appears higher above the horizon than it actually is. This phenomenon means that the sun, moon, stars, and even distant objects like islands or ships, which should be hidden below the horizon, can be brought into view by the curvature of light around the Earth. The density of the Earth's atmosphere decreases with altitude, causing light from celestial objects to refract multiple times during its path. The magnitude of this effect is about the diameter of the sun or the moon. So, when you see the sun or moon just touching the horizon, they're actually one whole diameter below it. This means we get a little extra daylight thanks to this atmospheric phenomenon. The time difference between the actual sunset and the apparent sunset is about 2 minutes, effectively making our day longer by around 4 minutes due to atmospheric refraction. Discover the fascinating world of atmospheric phenomena as we uncover the mystery behind the apparent and real positions of the sun and moon during their rises and sets. Prepare to be amazed by how the refraction of light creates illusions in our sky.